The Arboretum's collection of woody trees and shrubs from Asia and North America shines every fall with a beautiful display of color. The leaves of many different trees here turn yellow, orange, crimson, red, and purple. But what causes this short, seasonal, but spectacular show, and why do they do it? Let's look at the how and why of this spectacular display. Many woody trees react to environmental stress such as lack of water, insect and disease attack, changes in the amount of light the tree receives, and more by dropping their leaves on purpose. The term for this is senescence. In temperate regions, many broadleaf trees and even some conifers will lose their leaves or senesce just before winter. This senescence is more of a strategy than a reaction. It's triggered by a combination of shorter day length and cooler temperatures, changes that can precede a cold winter in areas where the trees are native. After it's triggered, the leaves undergo changes that allow the energy stored in the leaves to be translocated and stored under the bark and in the roots of the tree. The stored energy is then available to the new leaves and structures as they come up in the spring, much sooner than when they would be available if the plant had to rely solely on photosynthesis alone for the energy to make them. Worldwide, many temperate plants use this strategy to cope with winter. However, trees and some shrubs of certain regions of the earth will also exhibit a spectacular show of bright, warm colors during this process. Temperate East Asia, North America, and some parts of South America, but not Europe, regularly have vast displays of bright fall colors exhibited by many different species of hardwood trees and also some conifers like bald cypress and dawn redwood. However, these colorful displays do come at a cost for the plants that put them on. Energy that would otherwise be stored in the tree for next spring's production of shoots and leaves is instead used to produce more pigments for the fall color display. Carotenoids, xanthophylls, anthocyanins, and other pigments are involved. Carotenoids and xanthophylls are responsible for the orange and yellow colors. They are present before the leaf starts turning color and are eventually revealed when the green-colored chlorophyll starts degrading. During this time, anthocyanins are produced that give leaves their bright orange, bright red, fluorescent pink, and sometimes almost purple colors. This production comes at an energy cost to the tree. So what could be the reason the trees do this? What benefit, either immediate or long-term, does the spectacular coloration afford the trees? There are several theories, but none have been proved as of yet. One theory is that the bright pigments mimic the bright colors of plants that are toxic both to animals and insects. For example, many plants in the Anacardiaceae like poison oak and Japanese lacquer tree that are toxic have bright red fall foliage. Another theory is that the production of anthocyanins, which are very good antioxidants, and the other pigments, which are very good sunscreens, help protect the biochemical pathways that the plant uses to resorb the nutrients in the leaves. There's also a theory that the colorful leaves might attract certain insects, keeping them active when they should be entering a state of winter hibernation, thus guaranteeing that the winter cold kills off large numbers of them. But whatever the reason for their beautiful colors, they're quite attractive to human beings. In the east coast of the United States, tens of thousands of people flock to New England's woody forest to view the 1 to 2 weeks of this brilliant color display. But here at the Arboretum, we have trees and shrubs that turn colors from all over the world. That makes our season quite a bit longer, up to 2 months. So come on by and take a look.